Good morning, everyone. Hope all is well. Hope everything's all right. Sorry about that. All right, hope all is well. Hope everything's doing all right. Let's see. Sorry for running a few minutes late. Got caught up on a few things. So we are looking at, well, last class, for those who came, we actually took a test. And let's see. I believe, yeah, we did chapter 13. So we're looking at chapter 14 today. Hold on 1 second. All right, so any questions or concerns before we get started? Is everybody doing okay? All right. Also, Jay Dean, I sent you a message in the chat. Okay, gotcha. Thank you. Yeah, because I was looking for that name. And when I was talking to you last class, I was looking for that name and I saw somebody who had a similar name, but that wasn't your name because then they messaged me about something else. So I was like, hold up, we talked. It is. So, all right. So I'm good. I'm good now. I remember that name. Okay. Thank you. All right. So let's go ahead and open up the notes. Yeah, I remember that. And so but see, I didn't see the Dean, but the Jade part, I was just like, okay, and I saw a name that was similar to that. So I thought that first name was the key. And it wasn't. It's all good though. All right, so we are here. All right, so we're looking at simplifying rational expressions. Okay, so this is 14.1 for us, simplifying rational expressions. So a rational expression basically is a fraction, but this time when we're gonna have variables in our denominator. We can have them in the numerator as well, but we can have them in our denominator. That's most of the time when you call it a rational expression. But just a regular fraction is considered a rational expression as well. So once again, rational expression is just another term for a fraction. And so, it's a 5 over x plus 7, x plus 3 over x minus 5, x squared plus 3x plus 9 over x squared plus 5x plus 6, and then 10 over x. So all of those are just examples of rational expressions. All right. So here it says determine the function values if possible. All right, so they give us m of x is equal to x plus 3 over x minus 5. And they ask us to find m of 2. So really what would happen is they wouldn't give you any of this. And they just have m, parentheses 2, which is m of 2. And all that means that you're going to plug in 2 wherever you see x. And so that's where all of this come into play. So that'll be 2 plus 3 over 2 minus 5. And that'll be 5 over negative 3, which would be negative 5 over 3. That's your final answer. Here, I was just emphasizing the positioning of your negative. All three of these are the same. When you look at 5 over negative 3, negative 5 over 3 with the negative assigned to the 5, or negative without we're having a negative out front, then 5 over 3. All three of those are the exact same thing. It's just that as far as notation is concerned, the last two are what is normally accepted as your final answer. Normally, you do not leave the negative in your denominator. So you either bring it up top or put it out front as your final answer. And like I said, it's just notation. It doesn't change the value of your number. Questions? Very good. Right. Next one, same problem, but let's say they ask you to find m of 5. Plug in 5 in both places that you see x, and we end up having 8 over 0, which is undefined. So you can never have 0 in your denominator, and make sure you hold on to that because that's going to come up many times in these sections. Having 0 in your denominator is undefined. It's okay to have 0 in your numerator, which is what I was emphasizing right here. 0 in your numerator, 0 over 8 is 0. But whenever you have 0 in your denominator, that is undefined. All right, any questions so far? All right. So looking at this next one, we have P of V. That's V plus 5 over V plus 7. It says write the domain in set builder notation. So remember our domain, I believe we talked about domain in this class before. Our domain is what cannot be used, where your domain is what can be used for X. And so the way that we find our domain is to analyze what cannot be used for X. Well, in this case, it's for V. So that's what I have in the red boxes. You want to know what cannot be used for V. So what we're going to do is set our denominator equal to 0. The reason why we're doing that is because, remember, I just mentioned that we cannot have 0 in our denominator. So 0 in the denominator is what we're going to look for to figure out what value is going to stop us, or what value is going to create undefined. So you set your denominator equal to 0, V plus 7. And those we have V equal to negative 7. And that is the value that cannot be used. So before we go any further, is everybody okay with what we've done up to this point? We're trying to set our domain. The domain are all the values that can be used. So in order to find all the values that you can use, it's easiest to look at what you cannot use. So we found out that we cannot use the number negative 7. So they ask us to use set builder notation to set up our domain. So this is how you do it. You start off with, because our variable is v, you have v, it's a long line, and then v is. You talk about the description of v. So you have your braces, v in the long line, and then you say v is all real numbers, and v cannot be equal to -7. And then you close it out with the other braces. Right. Questions on that before we look at another one? All right. Now it says write the domain in interval notation. So this is our interval notation. You have to give an account for each interval. So we already, this is just a generic number line right here, but we know we cannot use -7, but I can get or use everything to the left of -7 and everything to the right of -7. I just cannot use -7. So this is how you would represent that. Negative infinity to -7. Use parentheses for your -7. What that means is I can get as close to -7 as possible, but I cannot use -7. So that's what the parentheses represent. Up against -7, so use parentheses. And then to the right of -7, I got -7 to the positive infinity. Once again, use the parentheses on your -7. That means I can get as close to -7 on the right side as possible. I just cannot use -7. So you start talking about -6.9, -6.99999. I can get as close as I want. Same thing on the left side, -7.1, -7.11111. You know, gets close to, or negative what, 7.0001. Get as close as -7 as possible. You just cannot use -7. So that's how you represent your domain. All right, questions. All right. Here we have f of a is equal to a plus 8 over a squared plus 5a minus 36. And okay, we're doing the same thing, same directions. Gonna write our domain in interval notation and in set builder notation. So remember what we did first was find out what are the restrictions. In other words, what values can I not use? So we set our denominator equal to 0. Our denominator is a squared plus 5a minus 36. So leaning on your factoring skills, go ahead and factor that to a plus 9, a minus 4. And that was the last section that we talked about, solving by factoring. And then I'll set each part equal to 0. That gives us a equal to -9, a equal to positive 4. So those are the two values. In this case, we have two values. Last time we only had one, which is -7. This time we have two values that cannot be used. In other words, when I plug in -9 into the function, I get 0 in my denominator. And then if I were to plug 4 into the function, I would get 0 as my denominator. All right, any questions? All right, set builder notation. You have A, the long bar. A is all real numbers, and A cannot be equal to -9 or -4. And then as far as interval notation is concerned, once again, you have to give an account for every interval you see on the number line. So you're talking about this interval, and this interval. So you go from negative infinity to negative 9 to 4, 4 to positive infinity. Notice I use union symbols to connect my intervals that represents or. And also, once again, we use parentheses on each one of our numbers, meaning that we can get as close to that number as possible. We just cannot use those numbers. Any problems? All right. So next thing in this section we'll emphasize is the simplification of irrational expressions. In this case, we have x squared plus 14x plus 45 over x squared plus 2x minus 63. So the first thing you want to do is to factor each expression. So you will factor them individually, factor the numerator, factor the denominator, and see what you get. If you have anything in common after that, just like you have any regular fraction, you can cancel out, what's in common with the top and bottom. So if I were to factor, these two out, I would have x plus 5 times x plus 9 over x plus 9 times x minus 7. Now we recognize that x plus 9 is what they have in common, so we cancel those out, and you're left with x plus 5 over x minus 7. That is the most simplified way of expressing this rational expression. Any questions on that? All right. So the next one, 3p minus 15 over 3p squared minus 75. So remember we said that the first thing you want to do is to factor out GCF if possible. So in this case, you see that we can factor out 3 from each expression. So that'll give us 3 times p minus 5. Then down bottom, 3 times p squared minus 25. Then we recognize we have a difference of squares. P squared minus 25. That factors out to give us p plus 5, p minus 5. Any problem with that? And now you cancel out what's in common. So we have 3 that can cancel out. Then we have p minus 5 that can cancel. If everything cancels out, notice everything in the numerator cancels out completely. Don't forget that leaves a 1. And that's your final answer. 1 over p plus 5. P plus 5 is still left in the denominator. All right, any problems? All right, so the next one, they gave us something, not something like this. They gave us this p plus 1 times p minus 2 cubed over p plus 1 squared times p minus 2. So, let's see, what am I going to do? Let's see. All right, so if you expand it out, p plus 1 appears once in the numerator, but p minus 2 appears 3 times. In the denominator, p plus 1 appears twice, but p minus 2 appears once. So I just expanded it out for it as many times as it gave it. And then what we can do, just like before, cancel out what we see that they have in common. P plus 1 cancels out one time, because that's all we have in common with both top and bottom. So is 1 p plus 1. And then there's 1 p minus 2. So this will be the result, p minus 2 squared over p plus 1. Now, once you get the hang of this, of course, you don't have to do this part. Expanded it out. You can see the connection between the exponents and what can cancel out and what can't and go straight here. But I'm just giving you an idea, a visual on what's actually happening. Any questions? All right. Here we have another one. 8y plus 8 over 2y squared minus 2y minus 8. So in this numerator, factor out the GCF of 8. In the denominator, factor out GCF of 2. All right. Now, numerator is factored out as much as possible, but here in the denominator, we factor out the trinomial. That'll be that y squared minus 3y minus 4. And factoring out the trinomial gives you y plus 1, y minus 4. So now we can cancel out. Now this 2 can cancel out into the 8, and that'll leave us with 4. And then y plus 1 will cancel. And that leaves us with 4 over y minus 4. Any questions?
How did you get did you times the -4 by 1? Is that what you did?
We said times negative 4 by 1. Are you talking about down here?
Above it, where it says 4.1.
Say it one more time, you little muffled.
It's where you have the 4.1 circled by the -4.
Oh, okay, yeah, I was saying this is how when you look at the factors of 4, what factors of 4 or two numbers that multiply to give you 4 will subtract from each other and give you 1, give you 3 in the middle. And so I was just saying that's how I got this 1 back here and the 4 back here, because I used this relationship, 4 times 1. Because 4 times 1 is 4, but 4 minus 1 gives me this 3. And so that's why I used 1 and 4.
All right, thank you.
Mhm. Any other questions before we look at 7.2? 7.2 still leans on the same thought process of factoring and simplification. And so that's what all of this is um, segueing us into. All right. So 7.2 will be 14.2. 14.2 for you guys. Yep. Multiplying and dividing rational expressions. All right, so when you talk about multiplication of fractions, if I had 2/3 times 9/4, you can multiply across and then reduce, or you can reduce first and then multiply. And that's what we're going to lean on now is reducing first and then multiplying. So if you were to look at the 9 and the 4, you can break it up into 3 times 3 and 9 and 2 times 2, and then you cancel out what they have in common. And that's what happened. Here, my 2's cancel, 3's cancel, and it leaves me just 3/2. Right. So let me erase some of this stuff. All right. So we have our original problem, which is this 5r squared s to the fourth over 28r s cubed times 14r squared over 20 s squared. All right. So what I did here in the next step was to break everything down to prime factorizations. So 5 is nothing you can do with that, but that 28 is 4 times 7. Then I broke down the 4 to 2 times 2. 14 is 2 times 7, and then 20 is 4 times 5. Then you break up the 20 into 2 times 2. I mean, the 4 into 2 times 2. So that's how I did each one of those numbers. All right. Any questions on that? All right. So from there, what I did was I canceled out any of my numbers, my coefficients, not looking at the variables. I was trying to do it, in pieces to make sure, okay, what's going on. So I didn't do everything at once. So there's a 2 that's in common with the top and bottom. This is 7 that's in common with the top and bottom. And there's a 5 that's in common with the top and bottom. All right, everybody okay with that? So as far as your regular numbers are concerned, what's left in the top is just 1 because all of the numbers canceled. And in our bottom, we have 2 times 2 times 2, and that's why we have 8 in our denominator. Then from there, you just multiply your variables across. I have r squared times r squared, which is r to the fourth, and then I still have s to the fourth up there. And then down bottom, s cubed and s squared will be s to the fifth. So that's why we have what we have right here. All right, so make sure we're okay with what is left before we go any further. So now we can still simplify. We have r to the fourth over r, and we have s to the fourth over s to the fifth. So don't forget, whenever dividing variables, you subtract your exponents. So that's what we did here. R to the fourth is r to the fourth over r is 4 minus 1 for your exponents. 4 or s to the fourth over s to the fifth is 4 minus 5. All right, so then that gives us this result. 1/8 r cubed s to the negative first power. And then you want to write your exponents with all positive exponents, so you drop the s down to your denominator. And this will be a more simplified expression. Any questions? So we'll do another one. All right, here we have 3w plus 21 over 16w to the 6 times 64w to the 6 over 9w plus 63. All right, so factoring out 3 from the first numerator, that's 3 times w plus 7. In the second numerator, 64 w to the 6. I decided to only factor out 4, because 4 times 16 is still 64, but notice I have 16 w to the 6, 16 w to the 6, so I'll be able to cancel out that whole thing. Now, if you didn't see that and you just factor out, break them all the way down to prime numbers, then you still get the same result. But if I see, something like this, then you don't have to do the extra work. You'll be able to cancel out the whole term. But the more times you do this, the more factorization you get into, the more you'll see things ahead of time, and you'll be able to take shortcuts like that. And then in this denominator, we factored out, second denominator, we factored out 9, and that leaves us with w plus 7. So now we cancel out what we see as in common. So w plus 7, that whole term of 16w to the 6. And also, this 9 has a 3 in it, so I can cancel out one of those 3's, which would leave me with a 3. So everything cancels out except for this 4 and this 3. And it gives me 4 over 3. One question. All right, so here, 7y squared plus 21y plus 14 over 35y plus 35 times y minus 2 over y squared minus 4. So once again, we're going to factor completely. First thing I do is factor out a 7 from that first numerator. Leaves me y squared plus 3y plus 2. Factor out 35 from the first denominator. Y minus 2, nothing we can do with that. But then y squared minus 4 is y plus 2, y minus 2. I still can factor out this trinomial right here. So that turns into y plus 1, y plus 2. So this is our complete factorization. We broke up that 35 into 5 times 7, so we can see clearly that the 7 will cancel out for us. And then cancel out what's in common. Y minus 2 cancels, y plus 1 cancels, y plus 2 cancels, 7 cancels as well. Everything in the numerator cancels, so that leaves us with 1. Only thing that's left in our denominator is 5, so that's 1 over 5. Any questions? You scroll up. Very good. All right, so now we're looking at division. Division, very similar. Still going to factor out completely. Still going to cancel out where possible. Don't forget the first thing division does is adds an extra step in which whenever you're dividing, let's have my eraser on. Whenever you're dividing, you're actually going to multiply by the reciprocal. So once you recognize that you have a division problem, you're going to change that division sign to multiplication and then flip the fraction that follows the division sign. Once you turn the multiplication, then you follow all of the multiplication rules that were applied in the previous examples. All right, so that's what we did here, 2/3 divided by 9/4. We didn't look to cancel out anything while it's in its current state of division. Change the multiplication first, then once it's in multiplication, you look to see if you can cancel out anything. In this case, we could not, so then we just multiply across, which is 8 over 27. So, first example like this, s over s minus 7 divided by s cubed plus 6s squared minus 7s over s squared minus 49. So notice the first thing I did was not to factor, but was to change it to multiplication. So the division sign, change the multiplication, and then I flip this fraction. So before I factor out anything, I go ahead and change my division sign to multiplication. And when doing that, like I said, that means you need to change the fraction or flip the fraction that follows the division sign. All right, so then from there we can factor each. S squared minus 49 is the difference of squares. So that's how we got s plus 7, s minus 7. Nothing will be factored in this first fraction, so that's why I went to the second one. Then in this third one, I'll factor out the GCF of s. Then also I can factor that trinomial right there. And let me erase this stuff. So this is the final factorization. All right, any questions before we cancel? So once you change it, once you change that division sign to multiplication and flip your fraction, it is the same process as what we did before. Canceling out, or you factor out completely, then cancel out what's in common. All right, so everything in the numerator cancels out completely, leaving you with 1. And then everything in the denominator cancels out except for s minus 1. Any questions? All right, next one. 6m squared minus 54m divided by m squared minus 9m over m squared minus 10m plus 9. So notice what I did here first. I went ahead and just wrote this as a fraction by putting 1 in the denominator of it. And then change division to multiplication, flip this fraction. From there, factor out as much as possible. So in the first one, we factor out 6m of equals with n minus 9. Second numerator, that trinomial will give us n minus 1, n minus 9. The second denominator, factor out m and equals with n minus 9. Once factored completely, cancel out what's in common. So everything in the denominator canceled out, and that left us with just 1. And then in the numerator, we have 6, n minus 1, n minus 9. Any questions? Mm-hmm. All right, next one. 5y minus y squared over y cubed minus 125 divided by y over y squared plus 5y plus 25. All right, so first thing we want to do, division to multiplication, and flip the, yeah, erase this still on. Flip the second fraction. All right, so looking at the first numerator, we can factor out y. That's what we did there. Now this first denominator is actually a difference of cubes. That's one of the last factorizations we talked about. And I'm just going up to see the whole formula. So that gives us y minus 5 times y squared plus 5y plus 25. And so how we get that is right here. We're going to use that formula. It's the formula right here in purple. If you have x cubed minus y cubed, in other words, if you have two perfect cubes, and that's what we have here. Y cubed is y being cubed, then 125 is 5 being cubed. So we would take the y, plug it in where we see x in the formula, take the 5, plug it in where we see y in the formula, and do our substitution, which is what we got. Now this is what we end up getting right here. The substitution is right here, and this is the final result. So from there we can cancel out what we see that they have in common. Y cancels, and then y squared plus 5y plus 25 will cancel. So anybody still copy that for sure. All right. All right, so what we're left with is, all right, so we have 5 minus y over y minus 5. Now, when you have something like that, notice we have a positive 5 right here, negative 5 right here, negative y, positive y. So we have opposite signs. If I were to rearrange my terms, which is what I did right here, if I just move the y to the front, put the 5 in the back so I can make a clean comparison to my numerator and denominator, I have negative y plus 5, positive y minus 5. So I have opposite signs in each. Okay. And you can look at it one of two ways. Either just factor out the negative in the numerator, y minus 5 over y minus 5 will cancel. Or you can just recognize that if I ever have opposite signs, each sign has to be opposite of the one in the denominator. Each sign in the numerator has to be opposite of the one in the denominator. In other words, negative y, positive y, positive 5, negative 5. Each one of my signs are opposite in comparison to the numerator and denominator. Just know that the result should be negative 1. We're not sure it should be. The result will be negative 1. And that's because of this right here. If you were to factor out negative 1, that'll leave you with just y minus 5 and y minus 5 minus y minus 5 over y minus 5 will cancel out completely. All right. Questions. Everybody good? Everybody straight? 7-3 is yep, is 7. This line is up. That's right. Let's see where complex numbers are. Okay. There's 2 sections. Let's see one more thing before I make this final decision. What we're going to do next. All right. So we'll pause right here. There's 2 sections. As far as class go, we have Monday off for 4th of July. So we should be good on that. Since we're not lecturing, let me see, do I want to do that? I can offer a test opportunity again on Monday if somebody's interested. I know it's a holiday. Well, 4th of July is actually Sunday, but we could do another test on Monday for anybody that's available. And it would be during this class period from 9 to 11. So, but let me know. Shoot me that email if you are going to show up for the test on Monday. That means, and as always, you take whatever test you're ready for. So it doesn't matter if it's test 1, test 4. You just come to class and I'll give you the password for that one, and you knock it out. All right. So, any questions on that?
Quick question: what is the homework for today? Is it 7, 1, 3, and 4?
14-1 and 14-2.
Okay, thank you.
Mm-hmm. Not a problem. I see one of your classmates taking shots at me. Look, I went to a funeral last weekend. That was supposed to be my rationale, my okay. I was supposed to get a pass this weekend. But
oh no, sir, no, I moved. I wasn't gonna have any Wi-Fi, so I was just curious. I missed the first portion from like 9 to 9:30, and then
okay.
it finally clicked back in at 9:30 because my phone's being weird because they're cutting off service and I have to move it.
Oh, okay. But see, that's how sorry,
not at all.
Look, that's how texting can get misinterpreted, because like if anybody looking at the chat, when this recording be posted by Monday, and then she did last, so it was like she taking a gentle shot at me, like you ain't posted last time till like Monday or Tuesday. And so no, I was just messing with you. I don't take none of that to heart. It's all good. And plus you put the smiley face behind it.
No, I didn't mean that nasty at all. I was just like, I just wanted to know because I'm not gonna have Wi-Fi.
Yeah. And see, that's why it's always good to talk versus just text stuff, right?
Yeah.
But yeah, it's all good though. Yeah, I didn't take anything against it. Like I said, since you put the smiley face behind it, it's easy to laugh at it. Now, if it was nothing but just straightforward. Are you gonna post it before Monday? Like, saying then I could have took a little bit of offense, but it's all good, man. It's all good. But yeah, the goal is, and if I can get a chance to do it today, I'll do it today. But yeah, and since you did miss it, I'll try to shoot that to you guys today. And you're great. You're a great student. You normally don't give me any flack, so like I said, I'll try to get that to you today.
Thank you, sir. I appreciate you.
Not a problem. Not a problem. Anything else? Anybody else? So once again, like I said, if anybody want to come on Monday, shoot me an email to let me know. All I need is one person that says yes, and then I'll be there. And like I said, just like for anybody who taken the test before under me, you come in, enable your camera. If this is your first time taking the test with me, I do need you to show me that ID. Other than that, once you're ready, I'll give you the password, and then we'll knock it out. All right. Anybody else before we close today? So everybody good? Straight. All right. So you guys have a good one. Be safe. Have a great 4th of July weekend. And I will see maybe a few of you on Monday, but class will not be until Wednesday. Have a good one.
Thank you, sir.
Thank you. Not a problem.
Thank you.
Thank you. Have a good one.